Today we're starting a new lesson, and this lesson is on scale factor. You guys are probably a little familiar with scale factor. It has to do kind of with the ratios and proportions part of math, which we haven't hit on too heavy this year, but I know you hit it very heavy when you're in 7th grade. So we're going to go ahead and get started. The objective for this lesson, which we'll be doing for the next 2 days, is to learn to make comparisons between and to find the dimensions of scale drawings, scale models, and actual objects in the real world. So kind of how to apply it to stuff in real life. Some vocabulary, new words that either are new or review. First is scale drawing. That's going to be a 2-dimensional drawing, so it's just flat. And it's going to be proportional to the real object, so it's going to have like the same shape, the same angles and everything, but it's just going to be in a smaller or bigger size. And then a scale just gives the ratio of the dimensions in the drawing to the dimensions of the actual or the real object. All dimensions are reduced or enlarged using the same scale if you're going to do a scale model or a scale drawing. So how do we read these scales? Like if you see a scale written A to B, it's hard for me to say A:B. If you see A:B, it's going to be read A to B. So I'd read this like this, A to B. If you're going to read a scale of 1 centimeter, 4 meters, so it would be 1 centimeter to 4 meters is how you would say it or read it. So here's a couple more examples. A scale of 1, 20 would be read as 1 to 20 or 1 unit to 20 units. The next one, 1 centimeter to 1 meter, so 1 centimeter to 1 meter. And the last one is 1/4 inch to 1 foot. So let's do some we-dos. We are going to do the length of an object on a scale drawing is 2 centimeters, and the actual length is 8 meters. So we need to find the scale. The first thing that we need to do is we need to write this as a ratio of the scale measurement to the actual measurement. So our scale measurement told us that it was 2 centimeters, and our actual measurement tells us that it's, in real life, 8 meters. And now, because of course life can't be, easy, got to make it difficult, you can see that we have 2 units that are not the same. So like for the scale we've got centimeters, and for the actual we've got meters. The nice thing about this is that it's in metric, so we're going to have to reference back to our king, dying drinking chocolate milk. So King Henry died by drinking chocolate milk, and what we're going to have to do is we're going to have to skip and jump from centimeters. So to go from centimeters, and we're moving up to meters, which is our base. So in order to do that jump, you're going to jump from centi to deci to base, or from base to deci to centi. So it's a 2 place movement. So for if we have 2 centimeters, and we want to put that compared to 8 meters as a centimeter, though, you would need to take 8 and you would need to move your decimal point 2 places, because that's how many we moved up here. So we're going to go 2. So it's 800. So now we have centimeter to centimeter. So now I've cleaned this up a little bit. So we've got 2 centimeter to 800 centimeter. The last thing that we need to do is we need to take a look at 2 and 800, and we need to decide if there's anything that both of these are divisible by, and they're both divisible by 2. So I'm just going to divide both of them by 2. So 2 divided by 2 reduces down to 1, and then 800 divided by 2 is going to simplify to 400. So my final scale for this problem is 1 centimeter to 400 centimeters. So the actual is 400 times larger than the picture that is going to be drawn. Okay, number 2 is a you-do, and I've been noticing that not having you guys do the you-dos and just kind of solving them for you is really starting to make it's making it harder when you go to do your practice, because you're not being forced to use your brain to do these, so I'm going to barely get you started, and I'm not putting the answers on here. So the length of an object on a scale drawing, so a drawing of it is just 4 centimeters. And I'll start this for you, but you're going to finish it. And then the actual length in real life is 12 meters. So I want you to use the same steps we just used with the King Henry died by drinking chocolate milk to move the decimal. And then I want you to divide them down as far as you can, reduce it, simplify it, however you want to think of it, to the actual either centimeter to centimeter or meter to meter. You should get the same scale either way. And then make sure that you have me check it for you. Okay, number 3, we're back to a we do. So this is a real-life example, something that might happen in real life. On a map, the distance between a waterfall and a buried treasure is about 4.5 inches. So on the map, it's 4.5 inches. And they tell us that the scale, they're giving us a scale. The scale is 1/2 inch is equal to 10 feet. So what is the actual distance between the waterfall and the treasure chest? So most important thing that we need to pull from this to start with is 1/2 inch to 10 feet. And now we need to go to our conversions because we need to figure out how many, because we have to get these either both into inches or both into feet. We have to figure out how many inches are in a foot. And hopefully you know that there are 12 inches in a foot. So if we're going to take feet and put it into inches, we need to actually multiply by 12. So this becomes 1/2 inch to 10 times 12 is 120 inches. So now we're both in inches. But I see that over here I still have a fraction, and I don't really want to have a fraction in my scale factor. In fact, I don't want to have that at all. So we need to multiply both of these times 2 so that we can get this to be equal to just 1 on this side. So I need to now do 120 times 2, which is equal to 240 inches. So our scale is 1 to 240, or 1 inch to 240 inches. So now that we know that our scale is 1 to 240, I'm going to write it like this. They have told us that the treasure chest distance from the waterfall is about 4.5 or 4.5. And we want to figure out what that means in real life. So the way we're going to do that is by setting up a proportion. Yay, I don't know if you guys remember these. So we're going to get x equals, because 1 times x is just x. And we're going to cross multiply 240 times 4.5. And that's equal to 1,080 inches. But before we move on, I want you to convert this back into feet by dividing 1080 by 12. So if you do that calculation, you get 90 feet. So that distance in real life is 90 feet. And that is our final answer. So that was a multi-step problem. So now we're going to do another one just like it, only it's got different numbers. So you'll get a chance to try these again. So on a map, the distance between a picnic area and the horseshoe pits is about 6 inches. So this is the part that we'll need to come back to in a little bit. But for right now, they're telling us that the scale factor on the map is 1/2 inch is equal to 12 feet in reality. So 1/2 inch to 12 feet. So we need to get these on the same playing field, and we know that each foot has 12 inches. So if we do 12 times 12, we're going to get 144 inches over here on our right side for our actual distance. And again, this one's being just a half, so we want to multiply both sides by 2 so that we can get this equal to just 1. So 144 times 2 is going to give us 288. So this is my scale that I'm going to start with in order to solve how far the picnic area is from the horseshoe pit in real life. So I'm going to clean this up. So now to come back to my situation, I've got the scale that we just figured out of 1 to 288. And our reality, or our drawing tells us that we are 6 inches on our map. So we need to solve for x in order to figure out how far the actual distance is, and we're going to do that by multiplying. So I'm going to multiply by cross-multiplying. We get x equals, 1 times x is just x. And then we need to do 288 times 6, which is 1,728, and that's in inches. But to know how far this is in feet, I need to divide by 12. So I'm going to divide that number, 1,728 by 12, which gives me 144 feet. And that is your answer. And like I said, again, these are multi-step problems. And they're taking us, a little bit of work to get to the final answer, but it's a real-life application where we might actually be able to use this in real life. Okay, number 5 is a you-do, and it's very similar to before. We have a scale drawing of an apartment building. So the apartment building, the second piece of info that you'll need in the second half, it's 25.2 inches tall or high. The scale is 1 inch to 3 feet. So you'll want to change feet into inches so that you can get your scale, and you're going to do that by multiplying by 12. And then you're going to take that scale and you're going to set up a proportion to solve for the actual height of the apartment building. So solve that, try it on your own, and then have me check it for you. The last part of this lesson is a scale model, doing scale models. So instead of doing 2-dimensional, scale models takes it into the 3-dimensional world. So the only difference is that this is 3D, which means that instead of having 2, you're going to have 3 dimensions to measure. So number 6, we're going to deal with a scale model. So a model of a 27-foot tall house was made using the scale of 2 inches to 3 feet. 2 inches to 3 feet. They want us to find the height of the model. So these are so similar to the ones we were just doing. We're still just finding that height. We're not going to actually do the depth. So technically this is just like doing a 2-dimensional. So if our scale right now is 2 inches to 3 feet, we still need to get these feet into inches by multiplying by 12. So 3 times 12 is going to give us, is that 36? Yeah, 36 inches. And now we need to look. Over here we have 2, and here we have 36. So we can divide, both of these are divisible by 2. So that's going to simplify down to 1 inch. And then 36 divided by 2 is 18. So our scale is 1 to 18. We have a scale of 1 to 18. And I'm just going to write this up here. Now we're going to pull in this piece of info that the model is 27 feet tall. So if our scale is 1 for the model, 18 for real life, and that's equal to 27 feet, wow, on our model, we need to solve for x to figure out what the actual height of the real apartment building is. This looks like it's going to be a pretty tall building. And we're going to do that by cross multiplying. So you start with x times 1, which is x just one x, so x equals, and then we're going to do 18 times 27, which gives us 486 feet. So that apartment building is 486 feet tall, which an average room I think is about like 13 or 14. So it's probably, wow, that's a building that's probably about 35 floors high. Okay, number 7 is a you do. This is the last problem, and I'm going to have you try this on your own. You're going to start with your scale is 4 inches to 2 feet. So you want to put feet into inches and then simplify to get your scale. So you'll write your scale. And then once you have your scale, you'll use it to set up a proportion where you'll put the smaller amount this side with the 24 feet. And then you can find out how tall the bridge is in real life. So have me check that. I'm not going to put the answer on here. And then you can turn these in to get credit.